Good morning. My name is Vaiyeen from 11 IPAB, and today I'm gonna talk about acid and bases. So first we have the table of content. First we have introduction, the definition of acid and bases. And second we have properties of acid and base. Third we have theory of acid and base, and then chemical reaction. Then we have the number of replaceable ions, equivalent mass, number of equivalent, and normality. So for the first part, what is acid and base? Acid is a substance that have pH less than 7, while base is a substance that have pH more than 7. How to identify the substance? Is it acid or base? The easiest way to identify the substance is using litmus paper. If the litmus turns red, the substance is acid. If it turns blue, the substance is base. Here are the properties of acid and bases. Acid have a pH level of 7 or below. Base have more than 7, and then the taste of acid is sour. The taste of base is bitter. If acid interact with red litmus, it will turn into red, and base, if it interact with red litmus, it turn blue. Acid contain H plus, while base contain OH min. And if acid did react with metal, but base doesn't. If acid interact with blue litmus, it turns red, but base, it will turn blue. And then acid is corrosive, but base is not. The texture of acid is sticky, and the texture of base is slippery. Here are the example of litmus test. Acid and plus any color litmus, it will turn red, while base, it will turn blue, and neutral, it will not change color. Here are the pH scale for every pH. So starting with 0, we have HCl, 1 stomach, 2 lemon, 3 vinegar, 4 wine, 5 coffee, 6 milk, 7 water, 8 blood, 9 baking soda, 10 milk of magnesia, 11 ammonia, 12 soap, 13 bleach, 14 drain cleaner. 3 theory of acid and bases. First, we have Lewis acid and bases. Theory that provide a very broad definition of acid and bases has been put forth by the American chemist called Gilbert Lewis. It defined an acid as compound that can accept a pair of electron, and base as a compound that can give a pair of electron. For example, Lewis acid is boron trifluoridec, and Lewis base is ethyl alcohol. Second theory, we have Bronsted-Lowry acid and bases, aka proton theory of acid and bases, introduced independently in 1923 by the Danish chemists Johannes Nicolaus Bronsted and Thomas Martin Lowry. This theory provides more general definition of acid and bases that can be used to deal both with solutions that contain no water. The Bronsted-Lowry theory stated that any compound that can transfer a proton to any other compound is an acid, and the compound that accepts the proton is a base. Example, HCl plus H2O equals to Cl plus H3O plus. So the HCl transfer the proton, and H2O accept the proton. Third, we have Arrhenius acid and bases. Was originally proposed and named after by the Swedish chemist Svante Arrhenius in 1884. Define an acid as a compound that can be dissociated in water to yield hydrogen ions H+, and a base as a compound that can dissociate in water to yield hydroxide ions OH-. Example, hydrochloric acid or HCl. Dissociate in water to yield the required hydrogen ions H plus, and also chloride ion Cl min. The base sodium hydroxide NaOH dissociate in water to yield the required hydroxide ions of OH min and also sodium ions Na plus. Moving on to chemical reaction that involve acid and bases. First, we have reaction of acid with reactive metal. Metal plus acid equals salt plus hydrogen gas. Example, Mg plus H2SO4 equals to MgSO4 plus H2. Second, we have reaction of acid with carbonates. Carbonate plus acid equals salt plus water plus carbon dioxide. So CaCO3 plus 2HACl equals to CaCl2 plus H2O plus CO2. Third, we have reaction of acid with bicarbonate. Bicarbonate plus acid equals to salt plus water plus carbon dioxide. NaHCO3 plus HCl equals to NaCl plus H2O plus CO2. Fourth, we have reaction of acid with metallic oxide. Metallic oxide plus acid equals to salt plus water. ZnO plus H2SO4 equals to ZnSO4 plus H2O. The fifth one, we have reaction of acid with metallic hydroxide. Metallic hydroxide plus acid equals to salt plus water. ZnOH2 plus 2HNO3 equals to ZnNO32 plus 2H2O plus 2H2O. The sixth one, we got neutralization reaction. Acid plus base equals to salt plus water. H plus OH min equals to H2O. The seventh one, we got reaction of base with ammonium salt. Ammonium salt plus base equals to salt plus water plus ammonia gas. CaOH2 plus 2NH4Cl equals to CaCl2 plus 2H2O plus 2NH3. The last chemical reaction is reaction of base with a metal salt. Salt plus base equals to salt plus metallic hydroxide. So the example is FeSO4 plus NaOH equals to Na2SO4 plus FeOH2. Now we're going on the chemical calculation involving the acid and bases. First, we have the number of replaceable ions. Refers to the total number of positive or negative charge of the ions and that compose a compound. Find the number of replaceable ions in the following substance. First, we have HCl. The number of replaceable ions is 1 because 1 times 1. Then H2SO4 is 2 times 1, and then AlOH3 it's 3 times 1. Then Mg3PO42 it's 6 because 3 times 2. Then H3PO4 it is 3 times 1. Now we are going to the second one, equivalent mass. Refer to the ratio between the relative mass of the given substance and its number of replaceable ions. The formula used here is equivalent mass equals to Mr per number of replaceable ions. For example, calcium nitrate CaNO3 2. The number of replaceable ion is 2 EQ per mole. So first we search in the periodic table the AR. Ca is 40, N is 14, O is 16. We add it all into this and then we'll get 164 G per mole. And then we find the EQM, Mr per number of replaceable ions equals to 164 per 2. We will get the answer 82 gram per EQ. The second example we got here, sulfuric acid. H2SO4. We find this in the periodic table. H is 1, S is 32, O is 16. The number of replaceable ions is 2 EQ per mole. So we add all the DMR. 1 times 2 plus 32 plus 16 times 4, 98. And then we find the EQM, MR per number of replaceable ion, 98 per 2, 49 G per EQ. The third example is hydrochloric acid, HCl. We find the AR first in the periodic table. H is 1, Cl is 35. Number of replaceable ion is 1. And then we find the MR, 1 plus 35, 36. And then MR per number of replaceable ion, 36 per 1 equals to 36 gram per EQ. The next one we have number of equivalent. Refer to the ratio between the given mass of a substance and its equivalent mass. The formula used is number of equivalent is equals to M per EQM. So the mass per equivalent mass. Find the example. Find the number of equivalent of a 20.5 gram of barium hydroxide. Given the mass is 20.5 gram, the item is BaOH2. The number of replaceable ion is 2 EQ per mole. And then we search the AR, 137, O is 16, H is 1. We add it all, 171. So we find the EQM first, which is MR per number of replaceable ions. So 171 per 2, 86. We round off to 86, and then number of EQ will be M per EQM, which is 20.5 per 86 equals to 0.238 EQ. Second example. Find the number of equivalent of 24.5 gram of sulfuric acid. Given the mass is 24.5 gram, the substance is H2SO4. We find the AR first. H is 1, S is 32, O is 16. The number of replaceable ion is 2 EQ per mole. And then we search for the MR. 2 times 1 plus 32 plus 16 times 4 equals to 98. We find the EQM, same as before, MR per number of replaceable ion, 98 per 2 equals to 49 gram per EQ. And then we find the number of EQ, which is the mass divided by EQM, which is 24.5 per 49, which is 0.5 EQ. Next, we got normality. It refers to the number of equivalent of solute per liter of a solution. The formula is N equals to normality equals to number of equivalent in solute and volume in solution in liter. The unit we use is EQ per L or normal N. Calculating normality in terms of substance concentration, which is molarity. Molarity refers to the number of mole of solute per liter of the solution. Formula that we use molarity is M times number of replaceable ion. Unit that we use in molarity is mole per liter. This is the derivation of molarity. N equals number of equivalent in solute per volume solution in liter, and then we change it M per EQM per V solution in L. We change it again M per MR per number of replaceable ion per V solution in liter, and then M times number of replaceable ion per MR times volume V solution in liter. And then M per MR is N. We put it here. So we transfer it up. N per number of N times number of replaceable ion per V solution in liter. And this how we get the formula. The example for molarity and normality. Calculate the normality of a 5000 milliliter solution made by dissolving 200 gram of sulfuric acid in water. Given V solution is 500 milliliter, we convert to liter 0.5 liter, and then the M solute, the mass solute is 200 gram. The substance is H2SO4. First, we search for the AR, which is HSO. H is 1, S is 37, O is 16. We find the MR, 1 times 2 plus 32 plus 16 times 2, 98 gram per mole. And then we find the number of replaceable ion, 2 EQ per mole. Then we find EQM. The formula is MR per number of replaceable ion, which is 98 here per 2, so 49. The number of EQ will be M per EQM. So the mass per the EQM, 200 per 49 equals to 4.082 EQ. And then the normality will be number of equivalent per the V solution in liter. So 4.082 per 0.5 will be 8.164 EQ per liter, or in normal. Second example, how many pounds of acetic acid or CH3COOH must be dissolved in water to produce 2 times 10 raised to 2 milliliter of 0.685 N solution? Given that V solution is 2 times 10 raised to 2 milliliter, change it to liter, 0.2, and then the normality is 0.685 normal. The substance is CH3COOH. So we find the AR first. CHO. C is 12, H is 1, O is 16. There is 1 to 2C, and then H is 4, and then O is 2. So 12 times 2 plus 1 times 4 plus 16 times 2. 60 EQ per mole. And then the number of replaceable ion is 1 EQ per mole. So we find the EQM, which is the MR per number of replaceable ion, which is 60 divided by 1, 60 gram per EQ. And then we find the number of EQ solute with the formula of N equals number of equivalent in solute per V solution in L. So we change it, so it will be equal to N times V solution in L, 0.685 times 0.2 equals 0.137 EQ. And then we're gonna search for the M. M is EQM times NO. EQM times number of equivalent. We use this in this one. So M equals to EQM times number of equivalent. 60 times 0.137 equals to 8.22 gram. We times by 1 kilo per 1000 gram to change it to kilo, and then we times it with 2.2 lbs per 1 kilo to change it to pound. So the answer will be 0.018 pound. That is all from me. Thank you.